Hi, today I'm going to show you how to multiply matrices. Let's get right into it. So first, for the general matrix multiplication formula. So you have a matrix ABCD, ABCD, and you're multiplying that by the matrix GH. So this is a 2 by 2 matrix, because 2 rows and 2 columns. And this is a 2 by 1 matrix, because there's, once again, 2 rows, but only 1 column. So for the result, you just need to keep track of all your rows and all your columns. So I'm gonna write out with a different color. So this is row 1, column 1, row 1, column 2, but because we don't have a second column, this is only a 2 by 1 matrix, we can cross this one out because we don't need it, and this is row 2, column 1. And if you had multiple columns in this matrix, you would just go row 2, column 2, row 2, column 3, and you get the idea. So let's actually multiply this matrix now. So row 1, column 1. So what you do is you take row 1 of the first matrix and row 1, column 1 of the second matrix. You multiply. Here, I'll just show you. See, what you do is AG plus BH. And the same thing, so it's going to close here, and the same thing for row 2, column 1. So you take CG plus DH. So, and then if you had actual numbers there, you could add them and get the resulting matrix without the plus sign or the multiplication signs. So that's it. Let's try an example now. Okay, so in this example, matrix A is a 3 by 3, and matrix B is also a 3 by 3. So AB, let's multiply that out and see what we get. So we do the exact same thing we did here. So row 1, column 1. Row 1, matrix 1, column 1 here. So 1 times 0 is 0. 0 times 1 is also 0, so we're just adding zeros here. And 1 times 3 is 3, so 0 plus 0 plus 3 is 3. So we can just write 3 here. And then we can go either across or down. So let's go across, because I always do it across. So 1 times 4 is 4, and then 0 times 0 is 0. And 1 times 2 is 2. So 4 plus 0 is 4, and 4 plus 0 plus 2, 6. So we have 6 here. And then row 1, column 3, so 1 times 2 is 1 times 2 is 2. And then 0, and then there's 2 zeros here, so that's going to be 0. So we just have 2 plus 0 plus 0, so this is 2. And then we can close the matrix here. And now we have row 2, column 1. So 0 times 0 is 0, 2 times 1 is 2, and then 3 times 3 is 9, so 2 plus 9 is 11. So we have a double-digit number here. And now column 2, same row, 0 times 4, 0, 2 times 0, 0, and 3 times 2, 6 again. And now the last column, so 0 times 0, 0, and then there's 2 zeros here, so that's just 0 plus 0 plus 0, so that's 0. Now, and we have the last row and the first column. So row 3, column 1, 0, 0, 0. So the answer is 0. Yay. And now 1 times 4, 0, and zeros here, so 4. And 2 times 1, is 2, and the rest are zeros. So 2 plus 0 is 2. Boom. Okay, so we multiplied two 3 by 3 matrices, and we got a 3 by 3 matrix. Is there a pattern here? Now let's use the same matrices A and B, but instead of multiplying A times B, we're gonna multiply B times A. We're gonna multiply B times A and see if we get the same thing. So, row 1 of B and column 1 of A. So, that's 0, 0, 2. 0 plus 0 plus 2. Now, row 1, column 2, so 0, 8, 0. So that's 8. I have really easy numbers here because there's a lot of zeros, so I'm not writing it out like 6. 2 plus 0 plus 0, 8 plus 0 plus 0. We're just adding them mentally. Okay, if I did the math correctly, this is what we got for our resulting matrix for B times A. It's not the same as the A times B matrix. So that means, we can conclude from that, that matrices do not follow the property. So matrices do not follow this property. So 2 times 3 equals 3 times 2, but you can't do that with matrices. AB did not equal to BA. Okay, let's try one last example, this one. So here we have a 2 by 1 matrix, and here we have a 2 by 2 matrix. So let's multiply them now. So we do the exact same thing as we did in all the other examples. And we take row 1 from the first matrix and column 1 from the second matrix and just multiply them out, right? Okay, so 2 times 1 is 2 plus 2, wait. No, you can't use the same number. You have to use the number that's in this column. But there is no number in that column. What do we do? Oh no. So we need to multiply like some, that's not a 0. That's some number times 4. But we don't have that number. Okay, well, let's just skip that for now. And let's try to do this one. So 3 times 1 is 3 plus 3 times, no. There's another number missing again. So there is actually a whole column missing that would have made it possible to multiply these two matrices. But in this case, when it's just a 2 by 2 or a 2 by 1 and multiplying a 2 by 2 matrix, it's impossible. So notice that we tried multiplying a 2 by 1 matrix times a 2 by 2 matrix. And this number is what made the difference. Like, if this was a 2, if we had 2 columns here, we would have been able to multiply it. But because this is a 1 and this is a 2, we can't multiply it. But we were able to multiply a 3 by 3 times a 3 by 3, because these numbers were the same. So we had the same number of columns in one matrix to multiply by the number of rows in the other matrix. So these two inside numbers always have to be the same for you to be able to multiply the two matrices together. These numbers don't really matter. But the inside numbers is what matters. So this is not possible, and this is possible. I hope that made sense. So thanks for watching, and I'll see you in the next video.